Hi, Mr. Wyatt here, and we are working on this first worksheet from the yearly review, and I'm going to go through a few of the problems from today's lesson. Actually, quite a few of them. It looks like I'm doing 10 of them, so it might take me a couple of videos to get all these in. But let's look at number one here. We have the formula y equals 2.25x plus 10. And that represents the total cost to purchase roses online and have them delivered. Y equals the total cost. That's how much you're going to pay in total for the roses to buy them and to have them delivered. X and X equals the number of roses purchased. See, we're using X here because that number can change. If you're entering this number on a website, you can change. You can order 6 roses, you could order 9 of them, 12 of them, however many roses you wish. And once you substitute that in, it's going to change the total cost. The plus 10, by the way, that means they're charging a $10 delivery fee. Okay, so you're paying $2.25 per rose. Take that times X, the number of roses purchased, and now that gives you the total cost for the roses. Plus $10 to deliver it will give you the total cost. How many roses were purchased if the total cost was $28? Now remember, y equals the total cost. So we can substitute 28 in place of the y. Now I'm not going to put 28.00. I'm just going to put 28 for y equals 2.25x plus 10. Really what I've done here is I have rewritten that formula. Only now, instead of putting a y out in front, I'm replacing it or substituting it. I'm substituting 28 in its place because that is the value of y. That's the total cost. So this is a two-step equation that I need to solve here. We want to find out x, the number of roses. Let's get this part right here, 2.25x, to be by itself. I can get rid of the plus 10 if I subtract 10. That's the inverse operation. As long as I do the same thing on the other side of the equal sign, I'm allowed to do that. So this is gone. 28 minus 10 is 18. 18 equals 2.25x. Really, all I've done here is I have removed the $10 delivery fee. And by removing that $10 delivery fee, I find out that 28 minus 10, that means the roses are actually $18. Okay? So if they are $2.25 each, well, you're multiplying by what to get $18? And so I can undo this by dividing by 2.25. Divide by 2.25. That cancels out, and now we know what x equals. Whatever 18 divided by 2.25 is. Now you can do this by hand, you can use a calculator, but what would that be? That would be 8. X equals 8. I should show my work here, but you could use a calculator to do that. 18 divided by 2.25 does equal 8. Okay, 8 times 2 is 16. 8 times 0.25 is 2 more. That's 18 altogether. 16 and 2 is 18. So x equals 8. 8 roses. Okay. Number 2. What is the prime factorization of 540? This is where we can use those factor trees to help us split this apart until all I have are prime numbers for its factors that multiplied together would equal 540. So let's split this apart. You can split this apart a lot of ways. You can put 2 times 270. You could do 4 times 135, but who would ever think of that? You could do, 5 times 108, but who would ever think to do that? You could do 6 times 90. You probably wouldn't even think to do that. You know what most people would realize is since it ends in a 0, why don't we just put 10 times 54 or 54 times 10? Split it apart that way. And then we can split the 10 apart because it is not prime. 2 times 5 equals 10. These are both prime numbers. I'm going to circle them. By the way, 2 is the only even number that's prime. We still need to split apart 54, and some people are thinking, what? That can be split apart? Sure, it's an even number. We know 2 goes into it. But you know what? I also know 6 times 9 is 54. Then I'll split apart the 6, 2 times 3. These are both prime. I'll circle them. And 9 is 3 times 3. These are prime numbers here. So all of my circled values are the prime factors of 540. So now when I write this, I'm going to go least to greatest. I'm going to put the 2's first, then the 3's, and then the 5. Now, when certain factors appear more than once, use an exponent when writing the prime factorization. So I have 2 squared times, then I have 3 3's. So I'm going to put 3 to the third, and then times 5. And that's our prime factorization. You can test this by solving this. 2 squared is 4. 3 squared is 27. Does 4 times 27 times 5 equal 540? If you test it out, 4 times 5 is 20. 27 times 20 would be 540. So it does work out. 2 squared times 3 to the third power times 5. That's your prime factorization for number 2. By the way, the prime factorization has prime numbers. If you look through the answer choices on number 2, you're going to see some that have numbers that aren't prime. And so you know you can eliminate them right away. All right, number 5, the surface area of a cube is 486 square inches. That's all the part of the cube here that's green. It's not how much it holds inside. It's just the surfaces that are green here. They look kind of plasticky. What is the volume? You know, you could find the volume of this cube if you took the length times the width times the height, which are all the same. The length, width, and height in the cube are all the dimensions are the same. But all we're given is the surface area of this cube. It's 486 square inches. So all 6 faces combined add up to 486 square inches. You could imagine if you could see in here the back side of the box, or the bottom, I should say, of the box. And here's the back side of the box right here. If you could see through this, maybe now that helps to see all 6 faces of this cube. But aren't all 6 faces identical in size? They're all identical squares. It's a cube after all. So if you take 486 and divide that by 6, won't that give you the area of just one face? I think it will. So 6 times 8 is 48. Subtract that from 48, we get a remainder of 0. And then bring down the 6. 6 goes into 6 once. 1 times 6 is 6. I get a remainder of 0 when I subtract. So 81 square inches is the area of just one of the faces of this cube. Okay? Now, I want the volume. Honestly, volume is also equal to the area of the base times the height. And 81 square inches is the area of the base. See, it's the same as the base bottom down here, which would be 81. So if you want the volume, you could just take 81 times, what are the other measurements? Well, actually, if this is 81 square inches, can't I find the square root of 81? That's 9, isn't it? So I know this is 9 inches. This is 9 inches. This is 9 inches. The length, width, and height are all 9 inches. Okay, all the dimensions have to be the same because it's a cube. So it's 9 times 9, which is 81, times 9. So 81 times 9 will give us our volume, length times width times height, 9 times 9 times 9. And that equals 729. Look at my label though. It's cubic inches. Volume is always cubic inches. So we had to work backwards, starting with the surface area of the cube. We divided by 6 to find the area of just one face. And then once we know that's 81 square inches, the dimensions are 9 inches. 9 times 9 times 9, length times width times height, gives you the volume, 729. All right, number 6, what is the area of this kite? This now, you will not find the formula for this on that formula sheet that we use in grade 6. You need to just memorize this formula. To find the area of a kite, that's equal to 1/2 times d1 times d2. d1 and d2 are the diagonals. Here's one of your diagonals, distance across the kite that way. Here's your other diagonal, the distance across the kite that way. So the length of the kite and the width of the kite. So d1 is 12 plus 8, which is 20. d2 is 8 plus 8, which is 16. So we have to take 1/2 times 20 times 16. If you want, you can put 1/2 in parentheses also. Just go left to right. What's half of 20? 10. And what's 10 times 16? 160 square units. Area is always square units. And we're not given any other label here. Okay, so that's all you have to do to find the area of the kite. Take diagonal 1 times diagonal 2 and then cut it in half. Okay, and then find half of it by dividing by 2. You could take 16 times 20, which is 320, and then to find half of that, you can divide by 2, and that'll still give you 160 for an answer. All right, number 10. What fraction is equivalent to 0.05%? Ooh, we have to be really careful on this one. What does percent mean? Percent means per 100. Okay, so if you want, you can write this as a fraction by just taking 0.05, putting that over 100. It's really that simple because that's what percent means. It means per 100 or out of 100. Except I have a problem here. I don't want a decimal inside of my fraction. So what I can do here is, what can I do to move that decimal point 2 spaces to the right? 1, 2 spaces to the right. Well, I could multiply by 100, couldn't I? Because if you multiply by 10, whoop, it moves 1 space. Multiply by 10 again, whoop, it moves that 2nd space. So you've just multiplied by 10 squared, or 100. I'll do the same thing down here. I'll multiply by 100. Because we have to do the same thing on the top and the bottom of the fraction to keep it proportional to the original. So I end up with 5 when I move that decimal point right 2 spaces. Over 100 times 100 is 10,000. See, you just tag 2 zeros on the end of this. But we can simplify this by dividing both of these by 5. 5 divided by 5 is 1. 10,000 divided by 5 is 2,000. So the fractional equivalence to 0.05% is 1 over 2,000. By the way, there is another way we could have done this problem. Very quickly, I'll do this. Hopefully I won't run out of time here. You see 0.05%. Anytime you have a percent, you can change it to a decimal. If you move the decimal point left 2 spaces, those would get filled with zeros, and you end up with 0.0005. What place is the 5 in? We have the tenths place, hundredths, thousandths, 10,000ths. So it's 5 10,000ths, which is exactly what we had here. Simplify it and you get 1 out of 2,000.